Hey, welcome back to another episode of This Week with Cheek. Now, if you thought my dance moves were hype, wait till you check out this next method of solving a system of equations. Thanks for joining me today. So let's go to the board to check out our first example. So what you'll notice first is that neither equation is written in slope-intercept form. And so what we're going to do is we're going to take the two equations and we're going to add them together. So you want to make sure that your x variables are lined up, the term with your y variable is lined up, and then your constant is also lined up. So another name for the elimination method is the addition method. And so I'm simply going to draw a line up underneath the two equations. I'm going to add them together and see if one of the variables will eliminate so that I can solve for the other one. Remember, x is going to have a coefficient of 1 for that first term. Now, when I add 5 plus 1, I get 6x. So those two terms do not eliminate. But if you look at the term with the y variable, I've got 5 positives and 5 negatives. So when I add those two terms together, they're going to zero out or eliminate one another. And then when I add my constants together, I'll get 18. Next, we just want to use inverse operations to solve for x. So I divide both sides by 6, and we get x equals 3. Now, with any system of equation, we are looking for an ordered pair to be our solution. So we found our x coordinate, but we also need our y coordinate. And to do that, we're going to go to step 4 and plug in that value of x back into one of the original equations. I chose the second equation to plug back into. So 3 in place of x. And then using inverse operations, I want to get y all by itself. I'm solving for y now. So I divide both sides by -5, and I get y equals -2. And so I'm going to represent my answer as an ordered pair, x comma y, and it will be 3 comma -2. Let's take a look at our second example. So again, we have two equations. Neither one is in slope-intercept form, but I believe I can eliminate one of the variable terms by adding the two lines together. So we're going to go ahead and add these two lines together. When I add the terms with the x, I have 4 negatives and 4 positives. So that term is going to eliminate, leaving me with -3y equals 9. Next, I'm going to use inverse operations to isolate the variable. I'm going to divide both sides by -3. Now, I need to point out to you a mistake, and this is a mistake I made, but it's also a common student mistake. We are so used to solving for x, and when we use the elimination method, we're solving for the variable we did not eliminate. If you remember, I eliminated x, so I'm solving for y, not x. So I'm going to change this. I need to know what y equals, okay? I need to know what y equals. So I'm going to go here. 9 divided by -3 is -3. Okay? So that is what y equals. We're just going to cross this out. I've got to redo this. So I can choose either equation. Okay? I'm going to go ahead and choose the first equation. So I've got -4x plus 3. And instead of y, I'm going to plug in this value of y. And now I've got -4x minus 9 equals -5. And then I'm going to solve for x. I've got 9 on both sides. -4x equals 4. X equals -1. So remember, x comma y. I solved for y first. Then I found my x. So my answer, the intersection of these two lines, is -1, -3. Let's take a look at our third example. So both equations are in standard form, and isolating either one of the variables is not going to be easy. But when I look and I try to add these two equations together, 5 plus negative 2 is 3. That doesn't eliminate. 3 plus 3 is 6. That doesn't eliminate. So I'm going to have to multiply one of the equations by a factor in order to create a zero pair, or in order to eliminate one of the variables. So I'm going to go here, step 2, and I've got the same coefficient here, but I've also got the same sign. So I just need one of these terms to be negative, and they'll cancel one another out. So I'm going to multiply my second line by negative 1. And when I do that, I'm going to distribute that negative 1 to each term, all three terms. So negative 1 times negative 2 gives me positive 2x. Negative 1 times 3 gives me negative 3y. And negative 1 times 27 gives me negative 27. Now, when I add the two lines together, 5 plus 2 gives me 7x. You'll see I've got 3 positives and 3 negatives. So when I add, that term eliminates. Equals, I've got to add my constants over here, okay? So this should give me negative 42. I'm going to divide both sides by 7, and x is going to equal negative 6. I did solve for x that time. Now, once again, I need an ordered pair, so I've got to determine my value of y. So I'm going to take negative 6 and I'm going to plug it in. 5 times negative 6 gives me negative 30. Plus 3y equals negative 15. Next, I'm going to move this over here because I've ran out of room. Negative 30 plus 3y equals negative 15. I'm going to add 30 to both sides. And y is going to equal 5. Once again, that's the solution to this system of equations. Now let's take a look at our last example. This will be a challenge. So once again, when I go to add my two lines together, neither my x nor my y are going to cancel out. So I've got to multiply one of the equations by a factor in order to create an opportunity for one of the variables to eliminate. Here I've got the opposite sign, a positive and a negative. So the opposite of 12 positives is 12 negatives. So in order to eliminate 12 positives, I got to have 12 negatives. So I'm going to multiply the bottom equation by 3. That gives me negative 9x minus 12y equals negative 39. Now I can add them together. My y is going to eliminate, leaving me with negative 11x equals negative 33. Divide both sides by negative 11. And I get positive 3. Next, we're going to multiply. I'm going to place x equals 3 back into my equation. I get negative 6 plus 12y equals 6. Add 6 to both sides. 12y equals 12. And then divide both sides by 12. And I get y equals 1. So, oops. X equals 3. Y equals 1. I look forward to helping you better understand this method of solving a system of equations. Thanks for joining me for another episode of This Week with Cheek.